is pre-calc homework for section 5.4. We're going to graph log functions. Question number 7. You want to first look at, here's your parent function, which is y equals the log of x base 2, which is 2 to the y power is x. So you're going to plug, we're just going to use -1, 0, 1, and 2. That's good enough. And when you plug these numbers in for y, you get 1/2, 1, 2, and 4. So for this one, this is going to be a shift 3 units right. All you have to do is take the x values and add 3. So if you take your x values and add 3, 3 plus 1/2 is 3 1/2. 3 plus 1 is 4, 5, and 7. Keep your y values the same. And then that's all you have to do is graph those points. So 3 1/2 over 3 1/2 down 1, over 4 up 0, 5, 1, and 7, 2. And here's your graph. Now you're going to have an asymptote of x equals 3. So you can draw your asymptote if you like. That's the graph. Number 8. Again, you're going to use those same points. As a matter of fact, it's negative 1/2. Well, let's do -1, 0, 1, 2. So 1/2, 1, 2, and 4. Those are the points we're going to use on all of these because they're all base 2. So this one is a, you're going to multiply, it's a vertical stretch by 2. You're going to take your y values and multiply them by 2, and then take your y values and subtract 1. Those are your 2 transformations. So what you have here, you're going to keep your x values the same. So 1/2, 1, 2, we have no effect on x. So take your y values, multiply them by 2, so you get -2, 0, 2, and 4, and then subtract 1. You subtract 1, you get -3, subtract 1, subtract 1, subtract 1. So you're going to graph over 1/2 down 3, over 1 down 1, over 2 up 1, and over 4 up 3. And here's your graph. This has an asymptote of x equals 0. Next one. This one uses the same points. 1/2, 1, 2, 4, -1, 0, 1, 2. So for this one, you're going to multiply your y values by -2. So y multiply by -2. So if you multiply these y values by -2, you get 2, 0, -2, -4. Keeping the x is the same. And then you're going to add 1 to your y values. Adding 1 to your y values, you get 3, 1, -1, -3. And graphing these, over 1/2 up 3, over 1 up 1, over 2 down 1, and over 4 down 3. So this looks like that. Next one. Again, same points, 1/2. Step 1. We're going to shift your graph 3 units to the left, so take your x values and bring them over 3 units. So this is going to be -2 1/2. Subtract 3 here, you get -2. Subtract 3, you get -1. Subtract 3, you get 1. Then you're going to multiply the y values by 2. You multiply these y values by 2, you get -2, 0, 2, and 4. And then you're going to subtract 4. Take your y values and bring them down 4 units. So you get -6, -4, -2, and 0. and graph those points. Over 2.5, down 6, 1, 2, 3, 4, 5, 6. Over 2, down 4, 1, 2, 3, 4. Over 1, down 2. And over 1, up 0. Just like that. And the last one we need to graph is this one, which you're going to want to rewrite. Rewrite it as -1 times the log of 2x base 2 plus 1. So your parent function, your 1/2, 1, 2, and 4. Step 1, you're going to take, this is your a value, flip it. You're going to multiply your x values by 1/2. Okay? All of your x values have to be multiplied by 1/2. So you end up with, if you multiply this by 1/2, you get 1/4, 1/2, 1, and 2. Next step, you're going to go out here, multiply your y values by -1. Multiplying these y values by -1 gives you a 1, a 0, -1, and -2. And the last step, you're going to add 1 to your y values. 1 plus 1 is 2.
Daniel Smith, if you're in the building, please
0 and 1 is 1.
Jim
-1
in
and
the
1 is
comments.
0.
Thank you.
And you get -1. So graphing these points, over 1/4 up 2, over 1/2 up 1, over 1, 0, and over 2 down 1. There you go. On the back side, I'm going to go through these quickly. If you look at the first one, 37, all you have to do is write the domain. It doesn't matter what the, this is ln, which means log base e, but it's a shift 1 unit right. So if you're shifting your graph 1 unit right, your domain is going to be -∞, -1 to infinity. So this is a shift 1 unit, left. So if you shift your graph 1 unit left, your domain is going to be from -1 to infinity. For the next one, you're shifting your, it doesn't matter that this is log base e, this is telling you you're shifting your graph 2 units left. So you're going to go now 2 left, so your domain is going to be -2 to infinity. For 39, this is a reflection over the y-axis. So your graph, which normally looks like that, is going to be flipped this way. So your domain for this one is going to be -∞ to 0. And for 40, you want to rewrite this as the log of -x plus 2, take out a -1, which means reflection over the y-axis. I'm sorry, reflection over the, reflection over the y-axis, and then x minus 2. You have to pull out a -1 here. So this is going to be shifted 2 units to the right. So your domain for this one is going to be -∞ to 2. So you're flipping it over the y-axis, and you're moving your graph 2 units to the right. 2 units to the right. So it's shifted this way. So you're reflecting it. So first you're going to reflect it. It's going to be reflected, and then you're going to shift it 2 units right. So it's going to be this way. So your domain is -∞ all the way to 2. These two, what is the difference between these two? Though they're the same graph. These are exactly the same graph. 2 times the log of x, these are both base 10. These are the same graph. They are the same. And same with 42. They're the same graph. This 3 can go in front. You're going to learn the property It's the power property. You're going to learn that in section 5.5. So you're going to bring this, you can bring this out and it's the same graph. Okay. Now the last ones, you have to describe the transformation and then talk about the domain. For this one, this 2 is a vertical stretch by a factor of 2. A vertical stretch does not change your domain. Your domain is still going to be 0 to infinity, and your range is still going to be all real numbers. You're not shifting it left or right. Same with this. This is a shift 7 down. It's not going to change your domain from your parent function. 0 to infinity, and your range is negative infinity to infinity. That's not going to change it. But this will. This is a shift 4 units right. So if you take your parent function, which looks like that, and if you shift it 4 units right, what you're doing is changing your domain. Your domain is going to be 4 to infinity, and your range is still going to be all real numbers. Number 46 will change your domain because you're going to go 2 units left. So 2 left, and your domain is negative 2 to infinity, and your range is all real numbers. Last 2, and we're done. This is going to change your domain. It's going to be 3 left and 4 down. So if you looked at the graph of it, just do that. Here's your parent function. If you go 3 left and 4 down, you're going to be somewhere like that. So your domain now is going to be from greater than negative 3. So negative 3 to infinity, and your range is all real numbers. In the last one, you're going to go 2 units right. That'll change your domain, and 2 up for that. So this domain is going to be, your x values are going to be greater than 2. So 2 to infinity, that's your domain, and your range is all real numbers. And that concludes section 5.4, day 2 of graphing log functions.